importance of chemistry in food technology?
What is the importance of chemistry in food technology? So let us define chemistry first. So chemistry is the science that deals with the structure and properties of substances and with the changes that they go through. So that is basically what food technology is all about. In food technology, we process food. So doon pumapasok yung chemistry. As a food technologist, pinaprocess natin yung pagkain para humaba lalo yung buhay niya. So we add chemicals, or we add additives, or any substances that will help or that will be able to lengthen the life of the food. So kaya natin pinag-aaralan ng chemistry is para malaman natin kung ano ba yung dapat sa hindi dapat para magtugma sila at makuha natin yung gusto natin para dun sa pagkain. So that is my definition kung bakit, that is my understanding kung bakit importante yung chemistry sa food technology. Kasi nagpo-process tayo ng food, so kailangan natin malaman yung mga substances or chemicals na pwede dun sa natutugma o matutugma dun sa properties ng pagkain. So yun.
Importance ng chemistry sa food technology. Yung food technology kasi, sabi ng karamihan, kaparehas daw halos tayo ng HRM. Pero yung chemistry, yung isa sa nagbibigay ng gap between HRM and food tech. Kasi tayo mga food tech, nagdi-deal tayo sa pagkain, sa changes na nangyayari sa food with science explanation. So yung chemistry, importante siya kasi halos lahat ng changes na nangyayari sa isang food, ma-explain mo siya through chemistry.
created using Powtoon.
Why do people have different reactions to the same food? One person might love chocolate, while another person may find it too sweet. Some people love cheese, but others just think it's nasty. The reason for these differences is due in large part to the taste of food, but there are other factors too. The smell of food, its texture, its color, and its temperature also contribute to what's generally known as the flavor of food. The combination of all these factors tells us whether food is delicious, good, unpleasant, or downright disgusting. The flavor of food is due mostly to how it tastes and smells. When you eat, the most immediate sensation is taste, but you actually smell food as well. If you hold your nose while you eat, you'll notice that some foods will taste different. There are 5 taste sensations: sweet, bitter, sour, salty, and umami. Only recognized as a taste in 1985, umami is associated with savory foods, which includes meat and tomatoes. Smell is as important, if not more important, than taste. For instance, when people who have a head cold try to taste salsa and chips, they feel the textural crunch of the chips and the tingle of the hot peppers on their tongue, but they cannot taste the flavor-rich salsa with its onions, tomatoes, and peppers because they can't smell it. When we chew, aromas are released that activate our sense of smell by way of a special channel that connects the roof of the throat to the nose. If this channel is blocked, such as when our noses are stuffed up by a cold or flu, odors cannot reach sensory cells in the nose that are stimulated by smell, so we don't enjoy foods the same way. Without smell, foods tend to taste bland and have no flavor. A huge amount of chemical compounds contribute to the flavor of food. Chocolate, for instance, is a mixture of some 300 flavor compounds, and coffee beans contain more than 800 chemicals. Identifying these chemicals can help create a variety of artificial flavors that are used in nearly every food product out there, including potato chips, ice cream, chewing gum, and soft drinks. Chemists create artificial flavors from chemical compounds present in plants and animals. They use them in their natural state, or they process them to make new flavors. What's interesting is that we don't need all the flavor compounds in a given food to recreate its flavor. For instance, an orange contains 250 flavor chemicals, which all combine to create an orange flavor. But artificially flavored Tang, a powdered drink mix, has only 6 aromatic chemicals in its makeup, but it has a familiar orange-like taste. So we can get pretty close to proper orange flavors from just a few of its flavor chemicals. Artificial flavors get their characteristic odor from various compounds, especially esters, which are chemical compounds formed by the chemical reaction of an alcohol with a carboxylic acid. An alcohol is an organic compound with the general formula ROH, in which the R is a hydrocarbon group and the OH is a hydroxyl group. A carboxylic acid is a compound with the general formula RCOOH. For example, the formation of ethyl butanoate, one of the compounds that gives pineapple its flavor, is produced through the reaction of butanoic acid with ethanol. But wait a second, isn't ethanol the type of alcohol found in alcoholic beverages? That's true, but when it combines with the acid, it loses the characteristics of drinking alcohol. Likewise, acetic acid is the main component in vinegar, yet when it reacts with an alcohol, the flavor changes dramatically. When 2 compounds react to form a new compound, the properties of the new compound are not a simple combination of those original ones. They are completely different. If you use different alcohols and different acids, you obtain different flavors. You can compare that to combining 2 colors of paint. When you combine red and yellow, you get orange. Similarly, when you combine pentanol with acetic acid, you get pentyl acetate, an ester that smells a lot like a banana. Flavor chemists combine many chemicals to achieve a desired scent. Day after day, they test different combinations before settling on the one that will achieve the desired result. But don't expect to get a tour of a flavor and fragrance factory anytime soon. Those flavor formulas are carefully guarded industry secrets. At major food companies, you have to work as an apprentice chemist for 7 years before even getting a peek at the flavor formulas behind the world's most popular foods.